Welcome back to the channel. I'd like to thank everybody who's been watching and all the new subscribers. And I recommend that you subscribe if you want to learn and if you like this type of content. We go in depth in industrial wiring diagrams, industrial parts and troubleshooting, and just general installs and maintenance in the industrial world. So if that's something that you're interested in and looking into getting into, I recommend stick around and kind of have an insight on what it is to actually be in the industrial world. Today's video, we're going to go over a schematic drawing. This is a real drawing that I have used several times to troubleshoot a series of industrial ovens. These are actually batch curing ovens for an annealing process. But this oven could do basically anything an oven does. It just gets hot. That's what it does. It provides a flame and it gets hot. Now this oven source, one of the energy sources is natural gas, so it is not an resistance heater oven. So basically what we're going to be looking at is the electrical side of things and not the gas plumbing side or gas control side. So based off this schematic, I want you guys to kind of understand where to start if you're looking for a problem to troubleshoot. Now on this schematic, this is a 3-page schematic, and it kind of goes over all the electrical circuits that are present in the oven, and most of this is in the control cabinet. So that's where you're gonna mainly find everything, and I'll give you a little overview of the control cabinet. So this would be all the components in a control cabinet. So if you open up the whole manual, you can break down on the electrical side of the wiring diagram. It should give you a page that shows you your control cabinet. So this is good because it gives you a pictorial diagram as well as a schematic diagram. Now there's a third version of a diagram. It's called a ladder diagram that basically just shows you functions of controls, and it doesn't give you any symbolism. But we can do one of those next time on the channel. So basically this pictorial diagram will just show you kind of where your main breaker is. So if you're looking at this main breaker, which is basically your on and off disconnect, this is where your supply voltage will be coming into the unit. Now your supply voltage will be coming off a breaker somewhere else in the building or whatnot, or a disconnect panel. So this is where you would actually turn on and off the power on the oven, and this is kind of where you would be putting your lock for safety purposes and for locking this machine out if you were to do any maintenance in this cabinet. So you start out right here on your main disconnect, and that's what this is called. Okay, so this will be your main disconnect, and to identify your main disconnect here on the side, it also gives you a readout of which each item is in a numerical format. So it'll, here on the actual pictorial diagram, it'll give you a number version, and here in the description of that number version, it'll give you what that item is. Now if we look at our main disconnect, it would be numbered 1 disconnect, number 3, 4, and 5. So we'll go down to number 3, 4, and 5, and it shows you that number 3 is your actual disconnect switch or your breaker, but in this case they identify it as a disconnect switch, and that'll be 100 amp 600 volt rated, and it gives you a part number over here, and then your disconnect switch handle. Now a disconnect switch handle is a device that is used so that you can have the door closed and still turn on the disconnect or breaker. It's basically a linkage system that allows you to have the door safely closed, and you're allowed to turn it on and off. And then 5 is a disconnect shaft. So that's just part of the linkage system on the on and off switch for this disconnect. So that would kind of tell you that. So if you're going to be looking at this disconnect, what does it look like in schematic form? Well, let's have a look at that. So right here, this is going to be your schematic form for that disconnect. And we'll zoom in a little bit, and there it is. So this is your number 1 disconnect. It's titled right there 100 amp. So this is what it looks like in schematic form, and you're going to want to pay attention to that, because that's a lot of times where you're going to start on a piece of equipment. you always want to check your supply mains voltage and make sure that everything there is in working order and that you don't have any voltage drops across any of these legs. Now there's going to be a lot of learning curve involved into getting to the point where they any kind of client or customer says, hey man, yeah, go open up my panel and start seeing what you can do. They're going to have a lot of background in especially in industry. So if you're just getting into the field or getting into the trade of becoming an electrician, start off on the simple stuff. Learn your lighting switches, what input, line, load, and switch legs are, and learn your receptacles. And you want to learn your basic single phase before you get into three phase. So you want to learn your three-phase control and what that looks like and start understanding operation before you can really jump into the industrial field. But it's not far away. You'll get there fairly quickly. You'll learn. The difference is having access to this type of equipment. The only time you're going to have access to this type of equipment is if you're in the field. So how do I get in the field if I don't have access to this type of equipment to get my experience? So then you're going to have to take on kind of apprenticeship position in one of these companies, and you're going to have to learn as you go. So that's why I always recommend anytime you get the chance to do something different, take advantage of it. It's not added work. I look at it as an opportunity. So let's get back to the schematic. So here's your supply voltage coming in, and that's kind of where you would start. So if you look at the schematic right off the face, by knowing your symbolism, I'll know that I'll have 1, 2, 3, 4 motors here. So on this entire oven, the whole thing basically consists of 4 motors. That's all it is. It's 4 motors, different sizes that do different things, and a combustion burner. That's basically all it is. Now, there's a bunch of wiring in between that connect everything on a set of controls. And that's where the schematic just shows you which wire goes to which and whatnot. So if you look at this schematic, you have your supply voltage off your 100 amp disconnect switch, and then you come in and you got terminal block, and then you got some fusing. This fusing, I'll show you that right now. But then you got your higher voltage, which goes to your motor. So you got a whole set of fuses, 3 fuses per motor, 3 fuses per motor, 3 fuses per motor, 3 fuses per motor. So each one of these controls is exactly the same. So right out the gate, you can know, okay, I got 4 motors, all the controls are the same. So if you learn how to troubleshoot one, you can troubleshoot all 4. There's no difference. So this consists of a breaker and an overload, and then it goes right directly to the motor. So that's pretty simple. Keep it pretty basic. A lot of times when they're manufacturing a panel, they just run the same circuit over and over and over depending on what's needed. So if you look at where these other 2 wires went, so now we have 3 lines of power coming in, 3 heavy lines of power go feed the motors directly, and then you have 2 lines right here off of A and B taking off that are fused right here. And what do those do? That's going to be headed over to your transformer. Now if you look at this symbol, this is basically the universal symbol for a transformer. So this takes 480 volts because this is a 480 volt 3-phase system, and it steps it down to 120 volts. And if you could look right here, you see that this says 480 volts into 120 volts. So that will kind of tell you that, hey, these two wires right here take off into a transformer, and then they come out as 120 volts. And a lot of panels usually use the 120 volt to control all the larger loads. So that's kind of what that transformer is doing right there. So if you look at this panel, These controls are limit switches. You got some limit switches right here. You got a control relay, and it shows you on the face of your panel the oven lights and stuff like that. Um, so it's pretty simple to read. You got a valve control motor, intake dampers. Now these are just some modulating motors that are also on this oven, but these are off the 120 volt circuit, so you don't have to worry about big large power for these. They're very small little motors. They're just little actuators and stuff like that. So continuing on your 120 volt circuit, this circuit also runs down. So a lot of times these circuits are color coded, and in this case for this oven they're color coded red. So anytime you see a red wire, you know it's going to be 120 volts, and the larger black wires are 480 volts. And you'll usually know because they're going to be a little bit larger wire because they hold a larger load. So yeah, you can just kind of go through and read. They're pretty heavily identified, and everything's titled, and it also give you wire color coding right here. So that'll help you when you're navigating and troubleshooting. So fairly simple to read, nothing too complicated. Now here is my control circuit for to get the motor started. Now in order to start any of these motors, all these conditions will have to be met. So we have a circulation fan airflow switch. That's a safety switch. We have two circulation fans running in this big oven panel. So both of these switches would have to be met based off of this 120 volt circuit, and all these are wired in series. So you're gonna have to really know the difference between series and parallel wiring, and when and how to use them. And that's something that you'll learn in school if you were to take a course. You'll learn that in school. That's one of the basics, series parallel. So as long as you pay attention and you're not on your phone in class, you should pick this up fairly easily, and you should really know how to read schematics. So what I recommend to people, anytime you get a chance, grab a schematic and study through it. Jump on YouTube, watch these videos on explaining schematics. Now, one thing I'm going to tell you about schematics is they're boring. When you're learning and you're going through the learning curve in school, the schematics, they're pretty boring, and you're going to want to definitely be on your phone and do something else or whatnot. But I recommend that you pay attention and stay focused in class. It's very important that you walk away from class knowing how to do this, because the one time you're going to be in the field and you're going to be left alone and you're going to have to know how to troubleshoot, you don't want to be the guy that comes out saying, well, yeah, I didn't have enough information, or basically not closing the deal. You always want to close the deal. You always want to find the problem. So yeah, this is just some basics on what a control panel looks like, and we'll go back to this panel. So that'll be your main disconnect, and this will be the transformer that was in that schematic drawing. So this is just a pictorial form of what a transformer looks like. It's just a big piece of metal. These are your contacts which feed your motors, and this is just some other little controllers that are in there. These are all your little control relays. This is your whole fuse block. So a lot of times when they build out a panel, they'll keep everything in order, so you could really just troubleshoot through these fuses really fast. Now these fuses will feed a motor, and these fuses are also identified in the schematic. So pay attention to those things, and you should be able to, with some schooling, to navigate through a panel fairly easy. Now there are a lot of videos on YouTube that you can watch that'll help break this down, but I also have a video that I'll link in the end of this video to show you how I physically walk through a panel and what everything is. So I recommend that you watch that video and take some key pointers out of this content that a few of us are putting out to train the masses on what you need to do if you're in the face of a large 480 volt 3-phase control panel. So I want to thank everybody for watching, and I'm going to help make these schematics make sense to you if possible. and get you out there and get you safe. So I appreciate the view. I recommend that you subscribe. I want to thank you. I appreciate it.